Welcome to Flash Core, your sharpest source for daily headlines and deep dives. If you're new here, don't forget to hit that subscribe button and stay ahead of the curve. July 1st, 2025, a date that, at first glance, seemed destined to blend into the calendar like any other. But as the sun rose over cities across the world, few could have imagined the profound shift that was about to unfold. The day began like any other, with the quiet hum of routine. Yet, in a California lab, everything changed in a way that would ripple across the globe. Google's quantum research team, after years of tireless work and countless setbacks, announced a breakthrough that would redefine our understanding of reality itself. Using their most advanced quantum computer, they achieved what was once pure science fiction, the creation of a new reality, not in the distant cosmos but inside a machine. For the first time, humanity had built a window into a world governed by quantum rules. The news arrived quietly, almost unnoticed at first, but its implications were seismic, sending shockwaves through the scientific community and beyond. For generations, we've observed a single shared universe, believing it to be the only stage for existence. But what if that's just one page in an infinite book? What if reality is a vast library and we've only just begun to read? This moment is a turning point on par with the discovery of fire or the invention of the wheel, an evolutionary leap that will echo through history. It's not just about faster computation or solving complex equations, it's about interacting with the universe at its most fundamental quantum level, where the rules of nature are rewritten. The rules are stranger and more wondrous than we ever imagined. Particles existing in many places at once, realities branching with every decision. We now stand at the edge of a new frontier, with implications for medicine, science, technology, and even philosophy. The questions we ask today may shape the world for generations. What does it mean to be real, when reality itself can be engineered and explored? Are there other realities we can create or visit? Could we one day step into worlds born from pure mathematics and imagination? The journey to answer these questions has just begun, and the path ahead is as mysterious as it is exciting. We must proceed with both excitement and caution, aware that every discovery brings new responsibilities. The universe has invited us to a grander stage, one where the boundaries of possibility are constantly expanding. The curtain has just been raised, revealing a future limited only by our curiosity and imagination. Let's explore what lies behind it, together. The next chapter of reality is ours to write. To grasp this breakthrough, we need to understand the tool behind it, the quantum computer. Classical computers used bits, ones and zeros, like a light switch on or off. Quantum computers use qubits, which can be on, off, or both at once thanks to superposition. Imagine a spinning coin, neither heads nor tails but both. That's a qubit. This lets quantum computers explore countless solutions at once. Then there's entanglement, two qubits linked so deeply that changing one instantly changes the other, no matter the distance. By combining superposition and entanglement, quantum computers weave a tapestry of possibilities. They operate in a computational universe where all answers can be considered at once. This power lets them tackle problems impossible for classical computers, like simulating the fabric of a different reality. It's not just a faster computer, it's a new way of interacting with information. The universe itself becomes programmable. That's the quantum leap. At the center of this groundbreaking discovery stands Prometheus, Google's latest and most ambitious quantum marvel to date. It represents years of research, innovation, and the combined efforts of some of the brightest minds in the field of quantum computing. Prometheus isn't a desktop or a server rack, it's a breathtaking chandelier of golden cylinders, suspended in a labyrinth of wires and cooled to temperatures just a fraction above absolute zero. This striking design is as functional as it is beautiful, engineered to push the boundaries of what's possible. Such extreme cold is essential. It shields the delicate quantum states of thousands of superconducting qubits, allowing them to exist in a realm where classical physics no longer applies. Here, the ordinary rules of computation are rewritten. Carefully tuned microwaves coax these qubits into precise quantum states, orchestrating a complex and delicate dance. Each pulse is calculated, each adjustment critical, as scientists guide the machine through its intricate operations. What truly sets Prometheus apart is its revolutionary error correction. Here, groups of physical qubits are woven together to form stable, logical qubits, robust against the ever-present noise and errors that plague quantum systems. This unprecedented stability enabled Prometheus to run long, complex simulations that would have been impossible for previous generations of quantum computers. The real breakthrough came when the team used Prometheus not just to solve mathematical problems, but to simulate an entire hypothetical universe, one governed by entirely new physical laws, imagined and coded by the researchers themselves. In this moment, they weren't simply crunching numbers or running calculations, they were weaving a digital tapestry, a living simulation governed by rules no one had ever seen before. The machine delved deep, exploring the consequences of these new rules within a self-contained simulated reality, revealing patterns and phenomena that surprised even its creators. For the first time in history, a computer became more than a tool, it became a generative engine, capable of creating and nurturing a new kind of existence from scratch. Prometheus didn't just follow instructions or execute code, it made discoveries, uncovering truths and behaviors that no human had anticipated. The simulation ran for days, long enough for new, emergent properties to appear, unexpected phenomena that hinted at the birth of a new digital reality. In the end, the heart of the machine became the birthplace of a new reality, one that began as code, but grew into something far greater than anyone could have imagined. The experiment was simple in design, profound in result. Scientists programmed Prometheus to simulate a universe with altered physical laws. They initialized the qubits to represent a flat spacetime, then introduced a quantum ripple. Unlike a classical simulation, the qubits themselves became the fabric of this new reality. The team watched as their artificial cosmos evolved, hoping for stability and predictable results. At first, the system matched their models, a major success. But then, unexpected behaviors emerged, new, stable, particle-like structures formed, interacting in complex ways. The simulation generated complexity far beyond its initial programming. Prometheus hadn't just calculated a result, it had created a self-sustaining generative reality, a new existence born from quantum code. When we say a new reality was created, we don't mean a physical universe you can visit, walk around in, or touch with your hands. It's not a parallel world you could step into through a portal. Instead, it's something far more abstract, yet just as profound. Think of it as a self-contained world of information and complexity, a digital cosmos that exists entirely within the boundaries of code and computation. It's a universe made not of atoms, but of bits and logic, humming away inside powerful machines. Our reality is governed by physical laws, gravity, electromagnetism, the rules of quantum mechanics. But the simulation had its own entirely different set of rules, crafted by human minds and then allowed to evolve on its own. Within Prometheus, a self-consistent evolving system emerged, its own internal logic, its own phenomena, its own version of cause and effect. It was a world that made sense on its own terms, even if those terms were alien to us. Imagine a video game so complex, so rich in detail, that it starts generating new rules, new objects, and even new forms of behavior all on its own, without any direct input from its creators. That's what happened here, but at the quantum level, where the tiniest building blocks of this artificial universe interacted in ways no one could have fully predicted. The scientists programmed the basics, the initial conditions, the fundamental rules, but the complex structures that appeared were emergent, unplanned, and often surprising, like discovering a new species in a digital jungle. Like snowflakes forming from simple water molecules, new forms of matter and structure arose naturally from the artificial physics, each one unique and intricate, shaped by the underlying logic of this new world. This new reality is a stable, evolving pattern of quantum states, a universe of information constantly shifting and growing yet governed by its own internal order. It's not a place we can visit in the traditional sense, but it's a place we can study, poke, and prod, an environment we can experiment with, observe, and learn from. By exploring these alternate realities, we gain new perspectives on why our own universe is the way it is, and what might be possible in worlds governed by different rules. For the first time, we're not just observers of the cosmos, we're architects, shaping the very fabric of existence within these digital domains. It's the ultimate sandbox for understanding existence, a laboratory for testing the limits of reality itself. The boundaries of reality just got wider and the possibilities are only beginning to unfold. The positive impacts are staggering. In medicine, we could simulate quantum interactions between drugs and diseases, designing perfect cures in hours. New materials could be engineered atom by atom. Think room temperature superconductors or carbon capturing catalysts. We could simulate black holes or the Big Bang, answering cosmic mysteries. Artificial intelligence would leap forward, optimizing cities, economies, and even creativity. Financial crashes could become a thing of the past. This isn't just a new tool, it's a new way of doing science and invention. For the first time, we can design realities to solve our biggest problems. The promise: a cleaner, healthier, more intelligent world. The future is full of hope and potential. With great power comes great responsibility and real concerns. Quantum computers could break all current encryption, threatening privacy and security. Simulated realities raise ethical questions. If complexity emerges, do we have a duty to what we create? The technology could be misused for powerful weapons or deepen global inequality. It also challenges our sense of uniqueness. If our universe is just one of many, what does that mean for us? These fears are natural and must be addressed openly. Navigating this new frontier requires wisdom as much as wonder. History is full of revolutions, the printing press, the internet, but this is different. Past technologies let us manipulate the world as it is. Quantum computing lets us create new worlds, new laws of physics. It's the difference between reading a book and writing one. For the first time, we're not just observing the universe, we're authoring it. The scientific method expands. We can now experiment with the very fabric of reality. What if the strong force were weaker? What if electrons had a different charge? These are now testable questions. Classical computers describe, quantum computers create. Prometheus is a discovery engine, a portal to the adjacent possible. It's not just a faster calculator, it's a tool for exploring the unknown. The nature of science and our place in the cosmos has changed. We are now architects, not just inhabitants. The paradigm has shifted. So where do we go from here? Scientists worldwide will race to replicate and expand on this discovery. The next decade will be defined by the quantum transition, more powerful machines, new ethical frameworks, and a new generation of quantum engineers. Public understanding is crucial. This is a conversation for all humanity. This discovery forces us to ask, are we confined to one reality, or is this the first step on a much longer journey? The line between science and philosophy will blur as we explore existence itself. The future is not a path we find, but one we create. The adventure is just beginning.